to our live streaming session. Today we are continuing with our Hexagonal Architecture series, and we will be looking at the BlueZone project on GitHub, which is an illustration of how to implement hexagonal architecture with Java. And I'm also really excited that today we're joined with Juan. So we will be together discussing hexagonal architecture and its application on BlueZone. Also, as additional general reading materials for anyone interested in hexagonal architecture, here are the following useful links. So to get started, I will do some screen share to introduce a diagram, and then after that Juan will continue on and explain a bit more regarding the diagram. So here's the diagram regarding BlueZone, and what we can see here is the outline of the application, and on the left hand side we have the driver side, the driven side, we have adapters, we have ports on both sides. And we can also see usage here of the component UML notation. So this is a short overview from my side. So maybe Juan, if you wish, you could maybe explain a bit more about this diagram. I can continue sharing, or of course, any time that you want to screen share, also let me know.
Well, now is good with your screen.
Great.
Well, with this diagram, I wanted to show a more complex example than the typical that we always see. But complex in the sense of the number of ports and the adapters on each port, because the not complex in the sense of the domain part inside the hexagon. In fact, inside the hexagon, when we say the code, I just put all the files in a flat package, saying that it isn't a question of it isn't Hexagon architecture doesn't bother about the structure of the inside of the hexagon, okay? And the application is just a way of in the cities. I don't know in other countries, but here in Spain, in the cities we have zones that are marked on the floor with different colors. One color is blue, another color maybe green, red, or whatever. And depending on the color, you have a rate for parking the car. And the application is just a simpler way of implementing that application that has the driving actors, the car driver who parks the car, and a car inspector that checks that if the car is legally parked or not. Legally means that the driver has to buy a ticket for a period of time, and in the zone that he pays for the rate that the zone where the car is parked in. Okay, and so in the right side we have the interfaces that are required by the application for doing this thing. One thing it does is obtaining the rates from a repo, from a file in this case. Another thing it does is to storing the tickets that the driver pays for it, and they are stored in a database. And another thing is paying for the ticket, which the application will connect to a remote system payment. The interfaces are divided into the left interfaces are the provided interfaces, the the API of the application that they offers the functionality that the application offers to the users, right? We have a port that is for parking cars, which is used by the car driver, and another one that is for checking cars, which is used by the parking inspector. The other port, which is called for configuring a application, is used by the test cases in the sense that they need for testing the application, they need to, in the first stage of the test, they need to access the driven site. There are two, but basically there are two ways of doing that, of doing this, which are the test accessing directly the driven actor or through the API of the application. In this case, I've selected the case that we configured which is called the test fixture, the environment of the application, are setting up through the API of the application, which this is a special port. It is called for configuring application, but it has nothing to do with the configurator element that is which builds all the system together. But this has nothing to do with the configurator. Okay, maybe I could select the better name for this for setting up environment or for setting up application or something. But don't people don't have to think that this is the configurator. It has nothing to do with it. Right? This port is for inserting data in the database or preparing the file or preparing the remote system for those tasks. Okay, and that's why the test uses the provider interface that they are testing, and also the provider interface that is used for setting up the environment or for reading the environment in the assert phase of the test. And that's more or less the explanation of the whole application. If you have any question.
Okay, great. So I also wrote here that at any point anyone can write any questions at any time in the chat. So I will show questions later as they appear. And maybe I want to highlight a few things to the audience. I mean, just to summarize some key points of what you explained here. So the first thing which I found really important that you mentioned is that here we're illustrating complexity in terms of ports and adapters rather than domain complexity. Like here inside, it's a simple domain, but the complexity is in the fact that we are connected to lots of different things, how shall I say, externally. So that was one important highlight that I see here. And the other part that is an important highlight is how you drew the different actors that are using this system, the car driver and parking inspector, and how they are accessing it via these ports, that this is the API to the application. And the other interesting part, which we can get later into in more details, is, as you mentioned, this driver port for the tests, so that the tests access the Hexagon through the API, as opposed to directly accessing the driven ports, which is, I guess, an alternative approach.
Yes.
So, and the other also, I guess, relevant part is here how we have some adapters which are sort of storage, like files and database, but we also have an interesting one of communication with external system. So I think that up to now that this is good for an introduction to the overall system, and maybe now we could move over onto code screen share. So I'm now going to share my screen and to present the code in IntelliJ. One moment. Okay.
Maybe the complexity that you were talking about, maybe
Yeah.
it is shown overall in the configurator, in the startup,
Oh, yeah.
in
That's a good point.
the startup project is where all the pieces are built together, and there are a lot of ways of doing it.
Yes. So this whole thing about dependency
If you want me
configuration.
to explain it, I can share the code better and explain.
Yes. Yes. You feel free if you wish to share the code. Okay.
It can, do you see it?
Yes. Yes. I see it now.
Here in the picture, the configurator doesn't show, but it's an important element. Although it is not part of the pattern itself because the pattern doesn't talk about this element. It is very important because it is who builds all the system, all the pieces together. No?
Mm-hmm.
The task it does is from right to left. He first decide he selects for each driven port. He selects one of the strategies because this at last is to apply what is done here is to apply the strategy pattern, and we choose one of the strategies. Typically, in the driven part, we have for each port we have two paths, one for the testable and one for the real actor. Okay? So the configurator on each port selects one of the two and instantiate if for example if it is an adapter it has to create to instantiate this adapter, and the adapter implements the port and acts as the database. Okay, then using dependency injection in this case I I inject the selected adapter or actor. I inject it into the application in using the this is Java, and I do it injection in the injecting the dependency in the constructor. Okay, and then I build the application and shows the application is injected into the adapter. The not the application, but the provider interface, the interface that provides the application is injected into the adapter or the actor. Because the adapter, one thing that is important also is that the adapter is an optional element in the architecture. If the actor on the left or on the right matches the interface directly, it doesn't need an adapter. For example, a test double doesn't need an adapter because itself implements the interface. On the other
Mm-hmm.
hand, a file needs an adapter that implements the interface and access the file. Okay, and in the code, the configurator, there are many ways to implement the configurator. I have a module the the structure of the project it is written in the article that I put the URL in the README file. Here in the startup is the code that has the configurator.
Yes, and I think it's good that you're showing this startup. And another word for it is also a composition root. So
Yes,
as people are searching on the internet, so for example, Uncle Bob he uses the word composition root.
yes, yes.
Uh,
What we call, when I say Alistair and me. What we call configurator is what the most of the people call composition root. Is
yes,
the element that builds all the system together, which is placed near the entry point of the application. Here the entry point is in the startup. I have the entry point, which is if I remember well, the runner. The runner is the entry point to application. It, it has when we run the application, we run the BlueZone runner. Okay, it is the main. This is the entry point, and this entry point, that's also I have an adapter selector that's what I said before. He select he reads it reads the configuration the adapter for each port is read from a file. In this case, I have the file outside and I pass the file to the main. And the file is just a test file when for each port I put the adapter that will be selected.
yes, and I think an important point to note here. This is the whole concept about configurable dependencies. Here we have, let's say, the configuration is done via a
Yes,
configuration file, whereby in that configuration file we are configuring the dependencies, and then at runtime you're dynamically loading up those
exactly,
dependencies.
exactly. The configurable dependency is possible because the hexagon depends on interfaces, on the required interfaces. The constructor of the hexagon has the required interfaces as arguments, and so with adapter selector we select the implementation of those interfaces,
Yes.
which is done here. Here, for example, for the storing tickets, the database ticket store, the dependency configurator look up the driven port. The argument is the port, and the dependency configurator looks up for the implementation. We can see the dependency configurator. You see here the lookup is done with a. This is interesting also because there are two ways of implementing the configurable dependency, which are the injection dependency injection and dependency lookup. Here I mix both of them because I do it dependency injection but manually without the Spring, without any framework. Why is manually? Because I instantiate the adapters and I inject myself in the hexagon. But I don't have any framework like a Spring that do it for me. I do it manually. Okay, but this is the dependency injection equally. But how do I look for each dependency using a tool of Java 9 of the language? It isn't a framework neither. If I in the dependency configurator, Java 9 has a tool with service loader that it's like a service locator. who lookups, you pass it the type of the interface, and it looks up for any compatible adapter that implement the interface. That's why this is a lookup, really. This is a lookup that I use the lookup for then inject the dependency into the hexagon. I don't know if you explain it well.
Yes, yes, it's a good explanation. Essentially, we can either use dependency injection, or here we can just load the dependencies like dependency lookup. Essentially,
Then here
it's a good
in dependency injection, here I build the driven side. I build the application, passing the application. Here is the dependency injection. I pass the application the already built uh, adapters, and then I pass the application to the driver, where I look up the driver also, because the driver I have to look up the for the driver, because it's, if we see the diagram, I have to, once I have instantiated the application, I have to choose the driver, either in this case the web UI or the test. And then finally, when I instantiate the driver, I run it. If it is the web UI, it is run an application web, a web application, sorry, and it is the test, the tests are run. Okay. One thing is that I have to say that this example isn't finished yet, because there are much work to do yet, like programming of the adapters. But the tests, for example, are done, and the web UI also is done. If someone wants to, and what I say about the hexagon is here, the code of the hexagon. What is left here is to create. That is important to create. You can put it in this way also, because hexagonal architecture doesn't say how you have to structure the hexagon, but it is a good thing that we can create a folder called, or a package called ports, and inside ports another folder called driving, and another one driven for the ports, and to distinguish the ports from the other code. It isn't done here, but it is. It was in the past and it will be in the future, but not now.
Yes, and just to add to what you mentioned here, is essentially that in hexagonal architecture there is no prescription regarding what will be the internals of the hexagon. So it could be flat like that, or it could be packages,
Yes,
ports, driven driver, or it could be any other structure is
yes.
also valid.
Sorry, I don't understand the question. It would be
Yeah, so I just mentioned that there are multiple possibilities here. So it can either be flat, as was done here, or as you mentioned, you could split it into, port, having a package for ports, driver ports, and driven ports. But of course, someone also has freedom for any other
yes.
structure. Yeah.
The typical structure is the DDD with
Yes.
the two layers, application services and domain, and that's a mess about the word application, because people who are used to use DDD call application to the outer layer of the hexagon, but in hexagonal architecture, application is the whole hexagon, not just the ring around. around the domain. Okay.
Yes, that's an excellent point regarding a possible, I mean, future.
That's why here, for example, I call this hexagon, but I have to rename, to do a lot of rename here because this project was an old project, and now we have another ways to name things. Hexagon, for example, I don't like hexagon because just because we say that it is an hexagon, it doesn't mean that it is really an hexagon. To be an hexagon is more than just to put the word hexagon. To be an hexagon
Yeah.
is to have parts around it, and to protect the application with tests. If we put an hexagon inside an hexagon, that's not an hexagon because the tests are outside only.
Exactly. And so, I mean, an alternative name, if this is renamed, this could be called the application. I mean, this is
Application,
the
yes.
application in hexagonal architecture. And we also have a question now from the audience, which I will show and read out. So, okay, maybe with screen sharing, you could minimize.
Yeah.
Okay. So let's see, coming back. Okay. So it was a thank you message. Okay, so just one question related to how is the best way to structure the folders. I saw a lot of repositories with application domain infrastructure. Now here, since I think that this is a popular question, I would like to do now short Miro, maybe screen sharing, so that we could talk about the different possibilities regarding structuring, because I get this question a lot. So I'm just going to do a short screen share, let me see, of Miro. Okay, so let's see. Okay, hexagonal architecture. Regarding the different possible layers, but maybe we could even firstly get started with drawing the hexagon and clarifying the point about the word application, which you explained. So in hexagonal architecture, this whole hexagon is the application, right? That's what you mentioned, I mean, a few minutes ago. So the words hexagon and application are essentially synonyms. So we can say, hexagon, I mean, application is the hexagon. So the whole thing is the application. So I'll just maybe put it big. And when it came to that naming issue between the usage of word application versus the word application in, let's say, DDD or onion architecture, the problem is that, well, in DDD and onion architecture, the word application is used, as you explained, for this outer thing. So that's, for example, they use the word application here, whereas using the word domain for inside here. So this is what can be seen in DDD and onion architecture books, whereas this is the one that's like just pure hexagonal architecture naming. And I'd also like to draw in the part for clean architecture naming, which is yet another one. So with clean architecture, Uncle Bob calls this use cases, and he calls this entities. And maybe coming back to the question about this whole thing, so we covered the words application, domain, infrastructure, and the different meanings. Now, this is where there's also that problem about infrastructure. So in hexagonal architecture, we call it on the right-hand side, we call these driven adapter is somewhere here. Whereas in clean architecture and DED, people call it infrastructure. And similarly, let's say in clean architecture, also the word infrastructure. And in hexagonal architecture, what we call driver adapter. In these ones, it would be essentially presentation. So I'm not sure, Juan, do you have any other, commentary regarding this question about
it's okay. It's okay what you say. Just think that it's about naming. We prefer to say driving instead of driver. Driving.
okay, thank you.
To
Driving adapter, okay.
Because driver is more similar to driven. Now driving is to distinguish better the two words. Just that. I use driver in a sense that it means that it can be either an adapter or an actor. I call it driver to either a driving actor or a driving adapter is a driver. Either you know.
So just to check here, do I put driving adapter or driver adapter?
Driving adapter and driving actor. Driver, I use driver as a only word, referring either to driving adapter or driving actor.
Okay.
Either of them, because the adapter isn't. I mean, the driver is who is in touch directly with the application. If you have a driving adapter, a driving actor, and a driving adapter, the driver would be the driving adapter. Okay, in that case, that you are drawing, the driver is the driving adapter.
Okay. Do I delete this? Maybe I'll just if it's like that.
That's the driver because it is
that's the driver. So can we say synonyms? Driver
or driving adapter.
Okay, it's okay.
But imagine that you don't have an adapter, and you just have an actor without any adapter. If you just have an actor, the actor touch directly the application. There is no adapter.
Okay, let me just draw in I think that this is related to that whole thing about components and strategy. We have the case that we have the driver.
I think I'm messing it all. But this has nothing to do with the strategy or the components. It's just the concept of actor and the concept of the adapter.
Okay, let me just check. Here you're talking about the two possibilities. Either actor can directly communicate with application, or actor via the driver adapter communicates with application.
Yes, but without driver adapter, just adapter or driving adapter. The adapter will be driving adapter.
Okay.
And the actor will be driving actor.
Okay. Like this.
Now, and that will be driving actor also, driving actor.
Okay.
So now in this situation, in that situation that you are drawing now, the driver is the driving adapter because it's who is in touch with the application. And in the situation at the bottom, where you just have a driving actor, that is the driver.
Yeah. Okay. So
driver is either an actor or an adapter. But that's it in the left side. In the right side, we don't have any word.
If someone
in the audience have a word for the right side, please write there in the chat.
Exactly. So here is in terms of terminology. Whereas I just want to add one more other things for these other ones here. I forgot to write the word tests in terms of if someone is following, Onion or Clean Architecture. But here we just have the word driving. Okay, great.
Sorry,
And I
sorry, sorry for the mess. Sorry for the mess.
no, this is excellent because this causes, a lot of, I think, confusion due to the different namings. And yet another confusion is sometimes when people think of the application like Spring Boot application. Some people even think of application for the whole
That's
REST
another
API.
that's another confusion. People call application to the driver also.
Yeah, exactly. So it's good that we clarified it.
An, inter, an,
And
inter, an interesting here also is that the driving actor touching the application directly is the case of the test. The test doesn't
yes,
have any adapter.
yeah. So this is the case for tests. Okay. Great. So we also got a positive comment from Alistair Cochran. Thanks for joining. He liked that we're showing the different vocabularies. Nobody shows them all like this. So yes, thanks for that. And there's also a question from Alistair. So only question in DDD, do they say application or application layer? Okay, you are right. They call it application layer, and this they call domain layer. Yes, whereas Uncle Bob in Clean Architecture, he doesn't use the word layer at all.
But in DDD books, I've read application only two without
Okay, so
layer.
I will put here that perhaps both of them might be used interchangeably, and they could be, because even I maybe remember seeing multiple of those used. And similarly here, someone may maybe call the main, it refers to the main layer. And I guess another also difference is when we analyze this is that here it doesn't say anything about like domain modeling, whereas these ones are presuming a rich domain model. But here there is no such presumption either. Yeah, and that's why I like the GitHub project that you have, whereby you illustrated something with an anemic domain, illustrating that hexagonal architecture is unrelated to DDD. And also, thank you message from Alistair. Okay, great. So since we covered these questions, maybe we could continue on with the code demo. And I will again say when new questions come up. So if you wish, you can continue screen sharing further for
Yes.
the code. And I'll stop screen sharing now.
I think I did show
Yes. Excellent.
the startup. Well, I didn't say the whole structure. I used to split the code into modules when the application is complex enough like this, because in simpler application we have just modules, and we split the module into package, and it's done. But when there are too many adapters, and they are fat in code, I prefer to. I've always seen a Hexagonal architecture as a modular architecture, where I have the hexagon as a module, and the adapters or the actors surrounding it, independent, without any layer of so. Here this naming is also. I name the things, putting first the application, then the role. You see, hexagon, I will put application instead of hexagon, and then if it is an adapter, or here driver, I mean actor. I will put the application, then it is an adapter on an actor, and then the port which is attached to, and then the technology. This is a naming that can be improved if, because the site here you don't know if the adapter is driving or driven. You say you can imagine it because of the port he is attached to. For parking cars is a driving adapter, is a driving port, and this would be a driving adapter. But if you want it to be clear, you can add here a more word that would say driving or driven because of the site.
Mhm.
The action,
But just to clarify here, you're talking about, I mean, possible ideas for naming improvements that, let's say, you would firstly indicate, which side it's on, driver or driven, and then the word adapter goes after it. But for the tests, you would not be using the word adapter.
for the test would be, it would be here for a clear, it would be BlueZone driving actor for checking car test. Okay,
Hmm.
this this is the driver is here is the notion of actor.
Yes, and that's the point that you also explained when we were doing that drawing of distinguishing between driving adapter versus the
Here
driving actor, which is the case for tests.
here I put the driver as referring to driver actor,
Hmm.
but that's because previously I named it driver, but now I name it driving. This will be first the name of the application, BlueZone, then the name of the site that will be driving, then if it is a actor or an adapter, in this case an actor, and then the port, and then the technology. In this case, it will be BlueZone driven adapter. Sorry, adapter. This will be the fake. The fake is testable. The fake is directly the actor, I think.
Hmm.
If I am not right, maybe Alistair, if he's listening to this, it can do it. I think that the testable is considered, which we see the picture. I think that this will be an actor because it doesn't adapt anything.
Hmm.
That's my opinion, but I don't know if you are right or not.
Well, it is a bit subjective. I mean, there are different possible arguments, but yes, we could say that the word adapter is when, I mean, the adapter pattern is
Yes,
about when there's like maybe mismatch in interfaces. And so, for
yes,
example, when we have file adapter or database, okay,
yes,
I'll give maybe one example of database adapter. Let's say we're writing something in SQL language or using some ORM, but then we need to somehow connect it to how we specified the driven port interface.
yes.
Now, we have another comment from the audience. This is way too complicated. I'm lost. Now, this is a common comment that I do tend to see with hexagonal architecture, is that this looks very hard, but maybe we could take like 1 minute now to, I guess, reframe it in simple language. The simplest way that I see, I mean, all of these BlueZone hexagonal architecture is as follows. We have the application, and the point of the application is, well, to expose certain functionality to someone. The driving, the whole driver or driving side that's the side which is concerned with using the application. And the other opposite side, on the right-hand side, the driven side, is about connecting to, let's say, databases, file systems, external services, etc., etc. And when we're matching this diagram to the Java project, we can see that that the hexagon, like the application, is one module. And each of these adapters is also a module itself. Now, it would be great if Wayne, feel free to ask any follow-up questions. Specifically, feel free to specify maybe which parts are complicated so that we can clarify further. Okay, so maybe we could continue on, yeah, with the code demo.
Sorry, I understood that there is more question or not?
No, you can continue on.
Okay, okay. Well, there's a module for each actor or adapter, and another thing curious to show how does Java 9 is how it defines the adapters, how it is specified that an adapter implements an interface in the driven side. For example, each module has a Java file which defines these things. This has nothing to do. This is another. This could be messy with people think that this has nothing to do with UML component. Requires here means that this module uses this module. For example, the for paying SPY, the testable for paying uses the hexagon. Depends on the hexagon, but it is not a required interface. This has nothing to do with the UML component. Okay, and this means export that the module export this package. And services, here is the trick. Services are interfaces in Java 9 that another module provides an implementation for it. Here this says that the hexagon has the for paying service interface that is implemented by the by the testable. Okay, the adapter implements that services, and that's how it does then the what I refer at the init with the service loader. This is how he does the lookup of the implementation when
Mhm.
when it looks up for the implementation of an interface. He looks these sentences, and he looks for the implementations that you declare here with provides with.
Mhm.
And you select.
Okay, we have a question here. What does the SPY do? Is it possible if maybe you could open up the for paying, interface and the
Yes,
SPY, and so both the interface and the SPY, and to explain, both the
yes.
interface as well as the SPY.
Next one is here. For paying is a required interface, a driven interface. For paying, just this just makes an order or a request of for paying a ticket. The pay request pay request is for you. Pay request has three things: the ticket code, that you are paying, the payment card with you are paying with, and the amount of money.
Mhm. And maybe coming back to the interface, so essentially this
Yes,
interface, the driven port for paying, it's an abstraction over, so we have some external mechanism, like maybe some external web service,
yes,
which provides us the possibility that we can pay. But here we don't want our application to be coupled to an external system. So
yes,
here we're essentially making an interface. It's an abstraction over some payment system
yes.
somewhere.
Here it throws an exception is an error, and this is for I think that the question asked for the adapter.
Spy. Yes, yes. I think now that we explained the interface, we can now explain the spy.
The adapter simply SPY is a test double that registers the calls, the calls that
Hmm.
you do to the interface, but it doesn't access any remote system or anything.
Yes.
I just have a list of pay requests, which I call it payment spool, and each time I receive a pay request, I store it in the list in the spool in
Yes. So it's sort
in
of
the pay.
uh, we can say it's imitating the real thing, and also a general, I mean, comment. Okay, to viewers. So there are different types of test doubles. So test doubles include stubs, fakes, spies, mocks. So here the spy happens to be just one possible test double. Instead of a spy, maybe it could have been a fake or mock or like stub. It's just different. I mean,
Yes.
different types of test doubles
Here,
essentially.
here, for example, I simulate the exception with randomly. I throw an exception randomly, setting a have it here a certain percentage of of generation error. That's just a curiosity. So, but the spy just register the calls. The step is prepared with some data to return. If we see the step, I think that the step was the rates.
Yeah, so that's another test double.
The step, I think that the step was the rates. The step just uh, uh, add rates to a to a set of rates, and then return them when you ask for a rate. It's configurable a step. This is configurable step because you insert the rates and then you ask for them. Also, there are hard coded steps that you directly return a hard coded value, but this is a configurable step that I init in the startup module. I init with the values. Um,
Yes, yes. So this is nice that we got to see different test doubles, and I recommend whoever wants to find out more about test doubles, you can read, I mean, for example, Martin Fowler's article, Test Double as an Introduction to Test Doubles. But the main concept here is that for each driven port, we need to have a test double,
yes,
because then we can use these test doubles later when we're writing tests for the
yes.
application. Okay, great. So now that we've seen these test doubles, maybe what remains to be shown? You've shown, right, the driven adapters, I mean, the test doubles, and it remains to show the driver side.
The driver side is, for example, the test cases and the web UI. The test cases I have for showing, also for showing this is a demo, and I wanted to show that you can use different frameworks in different adapters. Here I use a framework called Cucumber with the given when then format for the test, and the I don't remember the language, the jerkin language.
Yeah.
Here the test ng that is similar to JUnit, but here I use the format when given when then also. But here I wanted to show that you can use different frameworks. We can see one of them, for example.
Yes, it's equivalent to write. I mean, whether we're writing cucumber tests or just like using a test ng or some other JUnit framework, like it doesn't matter.
In the article, I also have the screenshots of the results of the test. If someone want to,
Mhm. And the other
um,
also interesting thing to point out here is sometimes people think that Gherkin is just for UI tests, but you can use Gherkin, I mean Cucumber, for anything. And here, this Cucumber tests, it is targeting the application. It is
yes, I
not
think
targeting the web
I
UI.
think I think right the opposite. That that is for testing the behavior. That the behavior is just the app, not the UI.
That's an excellent point because the application in hexagonal architecture is the thing that's exposing the behavior,
Yes,
whereas the UI is just an adapter to the external world. It does not have behavior. It's just a like UI wrapper in a way,
and
to
just
expose the
and just
application to the
and
external
just
world.
is all that is all that HA. That is a use case subject. The UI is separating for the application is a use case subject, but applies to hexagonal also.
Mhm. Okay, so yeah, I guess we could see the
The web the
UI.
web the web UI is a Spring Boot here to show that in the adapters we are allowed to use frameworks. The UI is a Spring Boot application with templates, the screens, the controllers. Here are the templates. Just a Spring Web application that is run by the startup project. And here I
Yes.
have some screenshots of the application. This is the home. This is the use case of parking a car where you enter the car plate, the rate, and the amount. You purchase a ticket.
Mhm. And maybe you could also show in the UI part where does the UI call the driver port?
Yes, what is injected in the controller, I think.
Yes.
We have several controllers, or it is in the. I have to look for it.
Yes, wait, it's in the purchase ticket controller. I saw it there. Yeah. So I
Yes,
see here on line 30 that we are
yes,
calling car parker dot get all reds by name and that it's also a
yes.
dependency injected.
Here the dependency injection is with the auto wire. This is Spring notation. But here he receives the car parker for parking cars, which is the driving port. It receives the driving port into the constructor, and then it uses when you request this URI, it uses the for parking cars, and calls a method.
Yes, and then it maps it back to a form that's needed
Yes,
for UI display. So this model that occurs later, that is
yes.
due to web UI concerns. If this was a REST API, then we would be, let's say, returning some REST response. So that's the part about adapting, adapter.
Yes.
Okay.
If it was an API, a REST API, you return a JSON. But
Yes, yes.
uh, here is just a screen with the model and the UI, the UI components.
Exactly. So yeah, this could be a web UI, this could be a REST API, it could be a SOAP service, command line.
Command line interface also.
Yes, command line interface. We also have a question from the audience. So thank you for the content. What is the advantage of configuring dependencies via dependency configurator as shown in the beginning over the auto wiring done by a framework like Spring? So the question is, why did you have the dependency configurators?
That's no. So you can do it whatever you want with a Spring or manually. That's no. With manually, you have the advantage that you don't have to import any. I didn't use any framework, but some people are used to frameworks that they don't know to do it manually. But it's the same. In fact, it's the same.
Okay, great.
With the framework, you use the annotations or the instructions of the framework, and manually you call the constructor direct. It's you that you the calling.
Mhm. Okay, great. Thanks for that clarification. Okay, so since we've seen the UI now, I guess the remaining part is the tests and the different test frameworks that
Oh
you
yes, I
mentioned.
didn't show. Well, an advantage of using Spring is you have a lot of dependencies. Of course, Spring has a container. For sure, is if you have a lot of them, maybe it is it is it is easier to do it with Spring. But it has sometimes you can do it manually, and people use the Spring without having to do it. I was going to show
The tests.
the test for checking cache, for example, was test ng. The test ng. Here is a test, for example. I use the given when then, but even when then is done by me. With it's not like jerking that jerking has the keywords given when then.
Yes, so someone could write like this, given when then, or someone could write, arrange, act, assert.
For example, this test is car should be illegally parked when all tickets expired. If someone has all the tickets all his tickets expired, then the car should be illegally parked. That's what this test do. So the given part prepares the repository. Given these tickets as the repository, this inserts the tickets into the repository. When I check at current date, time, car parked in airwide with rate, this is where the system under test is called. In the when part is when you call the system under test with this data that you previously insert. and then in the then part, the other packet should be you check the assert, the result. You check the result of the one part with the expected. But this is a method will be to here, for example, in the one part is where I have the system under test, that is the port. I instantiate the port, and I call the method here.
Yes, and an important point is here when we say instantiating the port, we are instantiating the
Well,
port.
I didn't. I instantiate the system under test, not the port. Sorry.
Okay, thanks. Yeah, so this is the driver port, car checker. Is that the driver port?
Yes, for checking cars, that's
Yeah.
the system under test returns the instance. Is and the instance has has two ports, the for checking cars and the for configuring app that is for configuring the test. But finally, what this does is to return the the port.
Yes, the part
Uh,
about for checking part, that's the, I mean, port that's for regular users as well, and we just have to happen to be testing it here. And the one about for configuring app, that was done to avoid directly accessing the driven ports. So that here with
yes,
configuring app, we are going through the Hexagon API and not bypassing the Hexagon.
yes.
Okay, maybe we could also look at the other test project as well.
And the other one was Cucumber
Yeah.
for the parking cars. Cucumber was a little different. It has what is called the step depth. I didn't see this for a long time. I almost can't remember. This is the runner. This is just that when the configurator runs the test, call this and this called Cucumber. Okay. And I don't remember where. The test cases were in resources.
I think it's above. You have the step defs package where you have payment step defs, rate
Yes.
step defs.
This
Maybe click
was.
on some of those.
This is for the given when then parts.
Yeah,
Here is what you program the given when then parts.
yeah.
And the test cases are in the resources.
Hmm.
For example, the purchase ticket feature is where you put the jerking language. You put here even there are the following rates at the repository, and then this you program this step dev in the step dev package, and will receive the values that you just put here will be received by the Java method. That's the point. And here in the step dev, I have a scenario context where I configure when I get the system under test in the when parts. In the when parts, I call the scenario context.
Okay, great. So it's nice to
Yeah.
see this example with Gherkin. Now, another point that maybe you could explain is the choice to use the app configurator for, I mean, setting up versus directly accessing the driven ports.
Well, that's well, in fact, now in my projects, I do it the other way. I access it directly the driven site because one thing that some people, me the first, are wrong with hexagonal architecture is that the things that they don't say in the article, they are forbidden, and they are not. It's just that the things that the article doesn't say, you cannot say anything about them, but you cannot say that they are forbidden. So the article doesn't say that you don't are allowed to bypass the application to access the different part. So you can do it. The pattern doesn't forbid you. That's the thing that I was wrong the first time I read the pattern. So it's the advantage of accessing directly is that it is faster, and the cons are that you are coupled to the to the to the right components. If you do it through the API, you are not coupled to anything. You are coupled to the application, but you are, it's normal that
Yes,
you are coupled to the application. You are not coupled to the things on the right. It has the disadvantage that is slower, but because this probably we have to do validation and checkings, which which is which is also a disadvantage of the other way. If you jump if you bypass the application, you touch directly the database, you might insert corrupt data into it, not validated or something like that. Each option has its pros and its cons. Lately, I prefer to access it directly and to because it's faster. It's faster and I think it's easier. Maybe you don't
yes,
have to you don't have any API for this. You will have to program an API for this, which is a cons. Uh, you have always the chance to access it directly. But you know this, I did this because I was playing with different possibilities to do things.
yes, it's good to know that both options are, I mean, valid. Hexagonal architecture does not say one or the other, but essentially both options are valid. Okay, great. So up to now, we've covered the diagram. We went through all the various modules. Now let's see. There's also another follow-up questions. If we have no SQL, does the data live in the application? Now, as we look at this diagram, uh, here I'm not sure if the question is referring to no SQL databases or something like that, but the point is the database adapter, it is an adapter over SQL databases or no SQL databases or something. So the data lives in the database, and the database adapter, whether it's SQL or no SQL, adapts between, the adapts to the driven port essentially. Not sure if that answers the question, or you, Juan, if you have any other follow-up points on this
No,
question.
it will be just the technology adapter that needs the database. If the database is SQL, but it will be SQL. If it is MySQL, it will be MySQL. If it is Mongo, it will be Mongo. It depends on the technology of the database.
Exactly, and we can have multiple databases at the same time. So here, Even
Yes.
though in this diagram we see one database adapter, but there could be multiple simultaneously. So we could have simultaneously a Postgres DB adapter, a MongoDB adapter, or any other one.
Yes.
Uh,
Another point on databases is that you can have two of them, one for testing. Besides to have the test double, you can have a database for testing and a database for production.
mhm. And another also question, when you run these tests, do you run these tests whereby for the driven ports you use the test doubles, or do you also run the same tests with the like DB adapter and file adapter?
You can configure it like you want. That's why I have the the file here.
Yes. So in that one, we can, if we configure it, okay, that we're running the test cases, and then below, instead of test double, that we say, let's say DB adapter or something, then it would
You
be running it with the real database.
yeah, you can run tests against. That's what I what I wait. If you here select a database for testing, for example, that will be the same database that for production, but the data is for testing. And here you select the test. You are running the application with the test as drivers and the database as driven. It doesn't have to be. You can do it all the possibilities you want.
Yes, they are both independent choice. We can independently choose driver adapters and independently choose the driven adapters. So this means, I mean, if we run it with the test double, then the test that we're executing is a unit test, more specifically a sociable unit test. Whereas if we select to run it with the real database, then that same test now becomes effectively like an integration test. And yeah, we also got a message. Thanks. I want to put the data in close proximity to the application. So, I mean, the data is in the database, and the database adapter is what's the intermediary between the application and the database. Okay, great. Since we covered all the modules up to now, I'm interested in whether there's any other final remarks that you have, any other comments about BlueZone or Hexagonal Architecture that you wanted to tell us, or is this?
Well, I think that maybe the point of the UML component that people doesn't know maybe.
Mhm.
Maybe I've used some naming that people are not used to it. The left ports in sound architecture are called driving ports, and the left ports and the right ports are called driven ports. But there are Alistair has an article about it, saying that sound architecture is a particular case of a UML component. UML component is a configurable piece of software that physically it has also um, driving ports and driven ports, but it called them provided interfaces in the left and required interfaces on the right. That's why they name it. And the symbol is this. This is a provided interface, which means that it's an interface that is offered by the application for the client to use it. And this is with the socket. This is a required interface, which means that it's an interface that the application requires that another component or another thing would implement it. That's the new wording we have.
Yes, and I will just copy paste the link. I'm assuming you're referring to the also the document component plus strategy generalizes ports and adapters.
Yes.
So I'm copy pasting this into chat, and I will share it here so that whoever is interested can read. So it's on Alistair Cockburn's website. A component plus strategy. I also had a read of it. It was really great to read it, and I saw several of your diagrams there as well. So that's also useful reading for whoever is interested to find out more about this topic. So I think we covered all key topics up to now, and also at the bottom of this video we will have your Twitter link, as well as the links to the websites that we mentioned, and this is also further reading for whoever is interested. And additionally, thanks everyone again for watching, and feel free to connect with me also on social media. So I want to say special thanks, like Juan. We learned a lot today. It was
Thanks.
really
Thanks to
great
you.
to see this, to see how you explain the BlueZone, as well as
I
how
hope
it
I hope
ties
I, I
to.
hope I hope I didn't mess people more than they are with design architecture.
Well, many people do say hexagonal architecture is a complicating thing. Now
and
I
I've done
like
and I've done even, and I've done today even more complicated.
uh, you've done the most, I would say, generalized implementation of hexagonal architecture, because you actually illustrated the complexity, as you mentioned, complexity of hexagonal architecture, unlike the main complexity. So it was good to see this, and I highly recommend to everyone to look at the GitHub project, and we will have all of this in links in this YouTube below. So thanks again. It was really great to have this discussion, and thanks to everyone else. Of course, any of the viewers, feel free to write any additional comments also if you have on YouTube after this is over, and the links will be below. So thanks a lot, and have a good day. Bye.
Bye.